Hello, ladies and gentlemen. Today we're going to look at rectangles, rhombi, and squares. First of all, a rectangle is a parallelogram with four right angles. If a parallelogram is a rectangle, then its diagonals are congruent. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. All right. And a rhombus is a parallelogram with four sides congruent. So here's some theorems dealing with the diagonals of a rhombus. If a parallelogram is a rhombus, then its diagonals are perpendicular. If a parallelogram is a rhombus, then its diagonals bisect a pair of angles, of opposite angles, bisects a pair of opposite angles. If the diagonals of a parallelogram are perpendicular, all right, then the parallelogram is a rhombus. Okay, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. All right. And finally, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. All right, a square. All right, a square is a parallelogram with four congruent sides and four right angles. If a quadrilateral is both a rectangle and a rhombus, then it is a square. All right, let's turn the page and let's move on. Now let's use these theorems, beginning with the exercises on the next page there of your notes. If we go down to down here, all right, and it says quadrilateral ABCD is a rectangle. Well, that means the diagonals are congruent, and since they bisect each other, that means that all of these little half of the diagonals here are congruent to each other, all right? And if that's true, and we're looking for AE and CE are equal, well, that means 36, or 2x minus 4 equals 36. And that would mean that 2x is equal to 40. All right. Divide each side by 2 would tell you that x is 20. All right. BE was 6y plus 2, and CE is 4y plus 6. Well, that means those two are still congruent to each other. So that means those algebraic expressions are equal. All right, if we subtract 2y from each side and add 2 to each side, or subtract 4y from each side would give us 2y on the left, and subtract 2 from each side would give us 4. And when you divide each side by 2, you would find that y is equal to 2. All right, if BC is 24 and AD is 5y minus 1, those two sides would be congruent. They're opposite sides of this rectangle, all right, or parallelogram. All right, so they would be congruent to each other. By the way, these over here are congruent to each other as well. We know for certain. All right, so that means that 24 would be equal to 5y minus 1. And that means 25 would equal 5y, which means y would be equal to 5. All right, in that next one, we are given that BEA is equal to 62, and that should be 62 degrees, by the way. All right, and it wants us to find the measure of angle BAC. Well, if you were to look at triangle BEA, that triangle is an isosceles triangle, all right, because segment BE is congruent to segment EA. And 62, the angle BEA would be the vertex angle. So if you let this be x, then that down there would be x. So x plus 62 would have to equal 180. That would mean 2x plus 62 would have to equal 180. All right. And if we subtract 62 from each side, 2x would equal 118. Divide by 2 would tell us that x would be equal to 59. Okay, so x would be 59. Let's go down to number 5. If the measure of angle AED is 12x and the measure of angle BEC, all right, is 10x, 10x plus 20, all right, find the measure of angle AED. Well, in order to do that, we need to find x. And if you look at these two angles, they're vertical angles, so they're congruent. So 12x, and I'll write that right here, 12x would have to be equal to 10x plus 20, which means 2x would have to equal 20, which means x would be equal to 10. So there's your value for x, okay? And it did not want us to find x. It wants us to find the measure of angle AED, and we know that the measure of angle AED would be equal to 12 times our value we found for x, which is 10, which means that would be 120 degrees. All right, there's your work for number 5. In number 6, it tells you that BD is equal to 8y minus 4, and the AC is equal to 7y plus 3. Well, if that's a rectangle, those are their diagonal lengths, and they have to be congruent, which means that 8y minus 4 has to equal 7y plus 3. Okay, subtract 7y gives us y on the left. Add 4 on each side gives us 7, so y is equal to 7. Now, it did not want us to find y. It wants us to find BD. Well, BD is equal to 8 times that y value decreased by 4. And 7 times 8 is 56, and 56 decreased by 4 is 52. So there's BD. BD equals 52. So you could write that down right here. BD equals 52. Number 7. If the measure of angle DBC is 10x and the measure of angle ACB, all right, is equal to 4x squared minus 6, find the measure of angle ACB. Well, those two angles, angle DBC and angle ACB, they're congruent, because if you look at triangle BEC, those two angles are the angles that are represented by y, and that means they're equal, and that means we can replace one of those y's with 10x and the other one with 4x squared minus 6. All right, and that would mean that 4x squared minus 10x minus 6 would be equal to 0. Okay, all right, and I'm going to try to factor that by, or solve that by factoring. I'd first get that, well, let's just factor it. You can factor it. Let's see, I believe it's 2x, and let's get that 2 out of there. Let's divide everything by 2. That'll make life a lot easier. If we do, we'd have 2x squared minus 5x minus 3 is equal to 0, and then I'll come up here and factor it. Factor the quadratic term, that's x times 2x. The signs have to be different. Since those are different, I'll hold off. I need 3 and 1, so I need a 3 here and a 1 here, because the outer product is 1x, the inner product is 6x, excuse me, and when I subtract those, because these signs are going to be different, I would get 5, and I want this outer product, or the 6x, to be this sign right here, negative, and that would put plus here. So that means x minus 3 would equal 0, or 2x plus 1 would equal 0. This would give you x is equal to 3, and this one would give you 2x is equal to negative 1, which means x is equal to negative 1/2. Okay, and this is an extraneous solution right here, because if you put it in for 10x, then you get the measure of an angle equal to a negative measure, so that doesn't work. This is extraneous. All right, so there's the value of x. Now, it did not want us to find that value of x. It wants us to find the measure of angle ACB. So the measure of angle ACB would be equal to 4 times, we're going to put in 3 for x, 3 squared minus 6. That would be 4 times 9 minus 6, which would be 36 minus 6, and that's equal to 30. All right, so the measure of angle ACB would be equal to 30 degrees. All right, in number 8, they tell us that AB is 6y and that BC is 8y. It wants us to find BD in terms of y. Well, if you know that both of those diagonals are congruent, then BD is the same thing as AC. And if we use triangle ABC, we would have 6y squared, okay, one leg squared, plus the other legs, oops, I need my square there, plus the other leg squared, all right, and we're using right triangle ABC, all right, because angle ABC would be a right angle. So 6x, oh, that's y, excuse me, 6y squared, plus the other one is 8y squared equals BD squared, which is the same thing as AC, because they're the diagonals are congruent. All right, and 6y squared would be 36y squared plus 64y squared equals BD squared. All right, and 36, that would be 100y squared, would be equal to BD squared. All right, so then take the square root of each side. All right, and y would have to be positive, so you don't have to worry about the negatives. So BD would be equal to 10y. All right, let's turn the page. On the next page, it says to graph each quadrilateral. All right, I'll let you do that. You can do that on your own. All right, and determine whether the figure is a rectangle. And for number 1, you're using your distance formula. Okay, well, what you want to do is to use your distance formula, and your distance formula is right here. Okay, if you're given x sub 1, y sub 1, and x sub 2, y sub 2 as an ordered pair for points A and B, okay, then the distance between those two would be equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's your distance formula. Okay, so if we're going to look at the quadrilateral ABCD, all right, and we're going to figure out if it's, it says to determine whether the figure is a rectangle. All right, and what I would do is find the length of the diagonals, all right, because if the length of the diagonals are congruent, then that's going to be, excuse me, it's going to be a rectangle, excuse me. All right, so let's find AC, all right, by doing the square root of, if we're doing A and C, the second x coordinate is x, minus negative 3, which is plus 3 squared, and then the second y coordinate is 3 minus the first y coordinate squared. So that length of that diagonal would be the square root of 3 plus 3 is 6, and 6 squared is 36, plus 3 minus 1 is 2, and 2 squared is 4, so that would be the square root of 40 for that length, okay? The other diagonal would be line segment BD, all right? So line segment BD would be the square root of the second x-coordinate, 3, minus negative 3, which would be plus 3 squared, plus 1 minus 3 squared. That would be equal to the square root of 3 plus 3 is 6, and 6 squared is 36. 1 minus 3 is negative 2. Negative 2 squared is 4. So that would also be equal to the square root of 40. All right. So you can say that since the diagonals are congruent, all right, since the diagonals of this quadrilateral or parallelogram are congruent, then therefore it is a rectangle. So that one is yes, it is a rectangle, all right, since the diagonals are congruent. And by the way, you can do the opposite sides as well. All right, I'll leave that up to you. So yes, this is a rectangle. All right. Let's go to number 3. Well, let's do number 2. If you've done 2 of these, you can do all of them. All right, in number 2, it wants us to determine if it's a rectangle. Well, that means we need to find all the slopes, because each pair of consecutive sides would have to have opposite reciprocal slopes. So let's find the slope of line segment AB. All right, 3 minus 0 is 3. And negative 2 minus negative 3 would be negative 2 plus, let's see, where do we get to? The difference in the x-coordinates. That minus that would be 1. All right, so that slope would be positive 3. All right, let's find the slope of line segment BC. All right, so the slope of line segment BC, all right, would be equal to 5 minus 3, which is 2, and 4 minus negative 2 would be 4 plus 2, which is 6, and that would reduce to 1/3. All right, and then we look, are these opposite reciprocals? If they are, we need to keep going. If they're not, then it's not going to be a right angle at point B, the common endpoint of those two segments, and they are not reciprocals. So angle B is not a right angle. Angle B is not a right angle. Oops, excuse me, a right angle, which means that ABCD is not a rectangle. Okay, all right, let's go to number 3. We probably should have done each side up there as well, but we can do it right here real quick. All right, if we want to find the distance between A and B. All right, so we would do the square root of, let's do the x-coordinates. This minus that would be 1 squared, plus 2 minus 0 would be 2 squared. So AB would be equal to the square root of, that's 1 and 2 is 5. Okay, so AB is the square root of 5. Let's find BC next. All right, using our distance formula. So 3 minus negative 2 is 5. 5 squared is 25. And then 0 minus 2 is negative 2, and negative 2 squared is 4. So BC would be equal to the square root of 29. All right, now let's do CD. All right, that's the distance between these two. So 2 minus 3 is negative 1 squared, okay, which would be 1. And negative 2 minus 0 would be negative 2 squared, which would end up being, I need my square there. 1 plus 4 is square root of 5, okay. And now let's do the last side, DA or AD, however you wish to name it. Okay, so we're doing the A and D. All right, 2 minus negative 3 would be negative 5 squared. And then negative 2 minus 0 would be negative 2 squared. And that would be equal to the square root of, that's 25 plus 4, which is 29. And as you can see, each pair of opposite sides here are congruent. So it is definitely a parallelogram. All right, now we just need to check those diagonals. Line segment AC, so let's find the length of line segment AC. that would be the square root of 3 minus negative 3. That would be 3 plus 3, which is 6. 6 squared is 36. And 0 minus 0 would be 0. And that would be the square root of 36, which we all know to be equal to 6. So AC would be equal to 6. Okay, now let's find the other diagonal, which would be BD. Okay, all right, if we're doing BD, it would be 2 minus negative 2, which would be 4 squared. All right, and then negative 2 minus 2 would be negative 4. Negative 4 squared. And that would be the square root of 16 plus 16, which is the square root of 32. That's not equal to, that's not equal to 6. So for number 3, ABCD is not a rectangle. All right, let's move on. Next, we're going to look at the rhombi. All right. The diagonals are perpendicular, and each diagonal bisects pairs of opposite angles. Now, let's go look at use some of those rhombi theorems. All right. Let's start with they tell us quadrilateral ABCD is a rhombus. Find each value or measure. So if it's a rhombus, then these are right angles right here, and that angle right there would be congruent to that one, which would be congruent to that one, which would be congruent to that one. Okay, and all the little diagonal parts would be congruent right here. These two would be congruent. Okay, keep that in mind. Okay, that's what you would get if you put the diagonals of a rhombus in. Okay, excuse me. All right. Yes, that'd be an isosceles. Those base angles will be congruent, so would those. If the measure of angle ABD is 60 degrees, okay, find the measure of angle BDC. Well, if that's a parallelogram, which a rhombus is, by the alternate interior angles, those would be congruent, those two angles that we're talking about there. So the measure of angle BDC would be the same as the measure of angle ABD, all right, which is 60 degrees. Number 2 says find AE if AC is, find AC if AE is 8. Well, if that's 8, then EC is 8, and AC would be 8 plus 8, which is 16. So AC would be equal to 16. And number 3, all right, they tell us, or they say if AB is 26 and BD is 20, find AE. Well, AE, right triangle, AEB, we know that this is half of that 20, which is 10, and AB is 13. So we've got a 10. If you want right here, you got a little right triangle, okay? And AB was what? 26. So AB is 26. That's the hypotenuse, all right? 26. And let's see, BD is 20, so BE would be 10. All right, so that's and that looks like the short leg over here, 10. All right, so then that would give us this other missing leg here. So A squared plus 10 squared would equal to 26 squared. All right, 26 squared, I think is 676. So A squared plus 100 is 10 squared. And that would be, like I said before, 676. All right, and then we subtract 100 from each side, 576. Take the square root of each side. All right, that would be, A would be 24. All right, which is AE. So there's AE right there, 24. All right, the measure of angle CEB. Well, the diagonals of a rhombus, because it is a rhombus, are perpendicular, and that angle is formed by the intersection of those two diagonals. So each of those 4 angles at that intersection are right angles. So that would be a 90-degree angle there. Okay, let's go to number 5. In number 5, they tell us the measure of angle CBD is 58, okay? And by the way, if that's a rhombus, all three sides have to be congruent as well. Okay, I'm going to put 3 tick marks on each of those. All right, and if we know the measure of angle CBD is 58, and we're looking for the measure of angle ACB, well, what we can do is we can find the measure of angle BCD by doing 58 plus 58, because these diagonals, this triangle BDC is an equilateral triangle because of the rhombus having 2 congruent sides. And if that's 58, this over here is 58 because the opposite sides of those opposite angles of those congruent sides are congruent. 58 and 58 is 116. Subtract 116 from 180 to find the measure of angle BCD, and that would be 64, all right, and that diagonal bisects that 64 into 2 angles that are congruent. If you bisect 64, then that would be 32. So the measure of angle ACB would be equal to 32 degrees. All right, number 6. All right, if AE is 3x minus 1, and AC is equal to 16, well, if AC is 16, half of that would give you AE, and half of 16 is 8, so AE would be equal to 8, so 3x minus 1 would equal 8. That would mean 3x is 9, and that would mean that x is 3. So there's your value for x. Number 7, they tell us that the measure of angle CDB is 6y, and that the measure of angle, so 6y, ACB is 2y. Okay, well, those two angles that they give us have to be complementary, by the way. All right, so we need to take 6y, add it to 2y plus 10, and that would add up to 90. All right, so that would mean 8y plus 10 equals 90. All right, subtract 10 would mean 8y equals 80. Y would have to be 10. All right, last one on this page. They tell us that AD is 2x plus 4, and that CD is 4x minus 4. Well, if that's a rhombus, those are the sides of the rhombus, then they're congruent. So that means 2x plus 4 has to equal 4x minus 4. Subtract 2x from each side and add 4 to each side gives us 8 equals 2x. Divide each side by 2 gives us x is 4, or 4 equals x. Same difference, okay? Let's turn the page. Okay, all right. Conditions for rhombine squares. The theorems below can help you prove that a parallelogram is a rectangle, rhombus, or square. All right, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. If one pair of consecutive sides of a parallelogram are congruent, if one pair of consecutive sides are congruent, then the parallelogram is a rhombus. If a quadrilateral is both a rectangle and a rhombus, then it's a square. Okay, all right, we'll do at least 1 or 2 of these. All right, let's start with number 1. All right. In number 1, it says, given each set, determine whether ABCD is a rectangle, a rhombus, or a square. Okay, well, let's start by, first of all, given the vertices, determine, they're telling you that it's a parallelogram. Okay, so what we might want to do for that first one would be to, let's find, I don't know, you want to, well, they tell us it's parallelogram. Let's find the distances. Let's find the distance between A and B. Okay, so AB is equal to the square root of 2 minus 0 is 2. 2 squared is 4. 4 minus 2 is 2. 2 squared is also 4. All right, so AB would be equal to the square root of 8. All right, we're not going to simplify that radical even though we could. All right, we'll just leave it alone because some of us don't know how to simplify radicals yet. All right, let's go and find BC next. All right, so we're doing these 2 points, B and C. 4 minus 2 is 2, and 2 squared is 4. 2 minus 4 is negative 2, and negative 2 squared is 4. And that would also be the square root of 8, wouldn't it? I do believe so. Okay, all right. Next, let's find CD. All right, CD would be the square root of, let's see, 2 minus 4 is negative 2. Negative 2 squared is 4. 0 minus 2 is negative 2. And negative 2 squared is 4. So that's also the square root of 8. All right. Excuse me. All right. Wait a minute. If one pair of consecutive sides of a parallelogram are congruent, this is definitely a rhombus. And that means that if you find AD, it's also going to be, and we'll go ahead and do it, but you'll see that it's a rhombus because 2 minus 0 is 2, and 2 squared is 4, and 0 minus 2 is 2, and 2 squared is 4. So all 4 sides are the square root of 8 units long. All right, now, it's a rhombus. The only question is it also a square? Because if there's right angles, then that rhombus will become a square. If there's not right angles, then no. And by the way, if we can show one right angle, that's really all we need, because if you've got a parallelogram and it has one right angle, it really has 4. So let's go do that, and let's find the slopes of 2 consecutive sides. So we'll find the slope of line segment AB first, all right? So we would do 4 minus 2, which is 2, divided by 2 minus 0, which is 2, so that slope would be 1. Now let's find the slope of the next consecutive side, segment BC, all right? So we will do a negative 2 minus 4, which is negative 2, and 4 minus 2, which is 2, and that's negative 1. And are those opposite reciprocals? Or does the product of these two slopes equal 0? And the answer is yes. And that means that ABCD is a special rhombus, one in which it has 4 right angles, which we call a square. Excuse me, that's a square. All right, I'm going to let you guys pick up from here. If you have any questions, please give me a call or show up in a Google Meet, email me, whatever you need to do. Thank you. Have a good day. Bye.